In 20.2, we looked at angle, side, angle to show that two triangles are congruent. And now in 20.3, we're looking at side, angle, side. So the first method that we had in the last lesson to prove triangles were congruent was ASA. And now we're looking at side, angle, side. Let's take a look at what it requires. If two sides and the included angle, there's that word again, included. If you're an included angle, 37 degrees right now is an included angle because it's surrounded by two sides that I know. I know 46 inches and 74 inches. Well, here's 46 inches and 74 inches too. And 37 is right in between those two. And here 37 is right in between those two. So 37 degrees in both cases is an included angle. It's surrounded by two sides we know. So these triangles are congruent. Triangles are congruent by side, angle, side. When we look at two triangles, we have to kind of look at it and figure out which parts might line up and correspond. And you can see that 20 centimeters here. I see a 20 in both triangles, and I also see a 19. So I'm going to look at the angle that the 20 centimeter side and the 19 centimeter side make. And in this case, I'm just going to trace over it with my pen. I can see that they make a 45 degree angle here. But on this side, the 19 and the 20 together make this 43 degree angle. That's the included side. So I might have two sides. I might have this, but I don't have that included angle. So these triangles are not congruent. Looking at this triangle here, I notice that I see a 2.5 centimeter side. I see that in common on both triangles, so that's a good sign for them to be congruent. And I see this 1.7 centimeter side here. And if there's a side, there's a side. This angle becomes the included angle, angle D, and that's got one little arc through it, and it's the same as this angle right here, G. They don't give me numbers of degrees, but they do tell me that they are congruent. So since angle D is congruent to angle G, we have side, angle, side. So these triangles are congruent. Here's a rectangle that's got a diagonal drawn across it, and we are given now that this angle, which would be called angle SPR, that's this one, we're given that that is congruent to this angle. So, and I see that I have a 2-inch side. So I know I have a side and an angle, and if I draw the triangle, it'll show you what the included side is. So SP is a side, and then there's my angle, and I need to know side. I need to know something about PR. But if you take a look at this triangle up here, this is 2 inches, and I'm drawing this side that's 2 inches. That's the one I know. And then there's my angle. And then here's my other side. Well, it's the same thing. It's PR. PR is a shared side. It's in common to both triangles. And so if I were writing a proof, I could make a statement that says PR is congruent to PR by the reflexive property because it's equal to itself. As it sits on this triangle here, I'm going to just put a little double tick mark through that. I know if this is 2 inches and this is 2 inches, those two are equal. And now this is another side that is equal. So I'm going to write a statement that says triangle, let's call it SPR. And so I started at S, so this one's going to start at Q. And this went SP, it went down the short side, so this will be called QR. And then the long side is P. And the reason is by side, angle, side. I don't want to go so far as to solve this problem for you, but I do want to help you set it up. There's a couple of problems, and you're going to see a few more of these as we go into Module 20. And that is to find the value of x that would make both of these triangles congruent, or to find the value of a variable. Let's take a look at what we see. What we see right now is that I've got a 30-degree angle in both places. So in side angle side, there's my A, and I notice that I have 9 inches and 9 inches. So that's one side and one angle, and therefore these two sides here must be the same. So however long CB is, CB has to be congruent to FE. And if you take a look at how long CB is 2x, and FE is x plus 4, and then that just becomes a one-step equation. You can solve and find out the value of x that makes it true. But in these kinds of problems, it's really important to know what part is equal to another part. So for example, this side right here corresponds to this side, and if they're congruent, they have to be equal, because corresponding parts of congruent triangles have to be congruent.